In the present video, we will discuss the numerical problem on quantity discounts model with two price break. Let's see the problem. Find the optimal order quantity for a product. The price breaks for which are as follows. If the quantity lies between the 0 to 50, unit cost is 10 rupees. If the quantity lies between the 50 to 100, unit cost is 9 rupees. And quantity less than or equal to the 100, then unit cost is 8 rupees. The monthly demand for the product is 200 units. The cost of storage is 25% of the unit cost and the ordering cost is 20 rupees per order. So now we have to determine the optimal order quantity. So let's see the solution. So here it is given the two price breaks are given. So one is the 50, another one is the 100. So let's consider the first price break is the B1, which is equal to the 50, and the second price break is the 100. Let's consider the B2. So B1 equal to the 50 and B2 equal to the 100. And also given the monthly demand for the product is 200 units, which means let's consider demand D equal to the 200. Cost of storage is 25% of the unit cost. So let's consider small r equal to the 0.25. And ordering cost is 20 rupees per order. So let's consider ordering cost C0 equal to the 20. Let's see the procedure to solve the two price break model problems. First, always have to start with the lowest price. Then we have to calculate the EOQ. After that, check whether EOQ falls in that quantity range. If not, move to the next price level. When a feasible EOQ is obtained, compare its total cost with the next discount break quantity. After that, we have to choose the quantity with the lowest total cost. Let's see the solution. Step 1 is consider the lowest price and determine the EOQ value. So here there is given the three prices. One is the 10 rupees. Let's consider it is the C1. And second one is the 9 rupees. Let's consider the C2. And third one is the 8 rupees. Let's consider the C3. So I have to choose the lowest price, that is the C3. And we have to determine the EOQ. So let's consider the EOQ value is the Q3 star. So Q3 star equal to the root of 2D C0 by CH. And this formula we can be rewrite as Q3 star equal to the root of 2D C0 divided by CH. We can be written as the unit price into the small r. So here unit price is the C3, then C3 into small r. We know the all the values, then substitute. We will get the Q3 star equal to the 63.25. So next we have to, if Q3 star is greater than or equal to the B2, then place the orders for quantities of size Q3 star and obtain the discount. And second condition is, if Q3 star less than the B2, then go to the step 2. So at the 8 rupees, we got the quantity is 63.25. But actual required is, it should be the greater than or equal to the 100. We have to check here. So here Q3 star equal to the 63.25 and B2 is the 100. So Q3 star is less than the B2, then we should not obtain the discount. So next we have to go for the step 2. So step 2 is calculate the Q2 star based on the price C2. So second step is calculate the EOQ based on price C2. Here second price C2 is the 9 rupees. So at this C2 price EOQ value is the Q2 star. Then Q2 star equal to the root of 2D C0 divided by CH. This equation we can be written as root of 2D C0 divided by C2 into R. Here C2 equal to the 9 rupees. Then substitute all the values. We will get the Q2 star equal to the 59.63. Then compare Q2 star with B1, and also if Q2 star is lies between the B1 less than or equal to the Q2 star less than B2, then compare the total cost at the quantity of the Q2 star and total cost at the quantity of the B2. And if Q2 star is less than the B1, then you have to go for the step 3. So here observe. So we determine the quantity based on the price C2. But C2 required quantity should be lies between the 50 to 100. So Q2 star equal to the 59.63 units, and it is the lies between the 50 to 100. So in the second step, step A is first condition is satisfied. Then we have to compare the total cost with respect to the Q2 star quantity as well as B2 quantity. So how to next we compare the total cost for the quantity of the Q2 star with the total cost for the quantity B2. So we know that total cost equal to the purchasing cost plus ordering cost plus carrying cost. So first I have to calculate the total quantity for the Q2 star quantity. So first one is the purchasing cost. So for this one, so demand into the unit cost. So here unit cost for the quantity Q2 star, which is the 59.63, which is lies between the 50 to 100, and unit cost is the 9 rupees. Then C2 value is the 9 rupees, and ordering cost, number of orders into ordering cost. So number of orders D divided by quantity Q2 star into the ordering cost, plus carrying cost is the 1 by 2 into Q2 star into R into C2, that is the 9 rupees. Then total cost for the Q2 star quantity, which is equal to the, so D equal to the demand 200 and C2 cost is the 9 rupees plus 200 divided by 59.63 into C0 20 plus 1 by 2 into Q2 star 59.63 into R is the 0.25 and C2 is the 9. Then we will get the total cost for the Q2 star quantity, which is equal to the 1934.16. So next we determine the total cost for the B2 quantity. So total cost for the B2 quantity, which is equal to the D into C3. Why it is C3 mean B2 quantity, which is the for the 100 quantity unit cost is the 8 rupees. So total cost at the B2 quantity, which is equal to the 200 into 8 plus, so D divided by B2, 200 divided by 100, and C0 is the 20 plus 1 by 2 into, so B2 which is 100 into R into C3, so which is equal to the 8. Then total cost for the B2 quantity 1600 plus 40 plus 100, which is equal to the 1740. So here we have to compare the total cost of the Q2 star quantity and B2 quantity. So here total cost for the Q2 star quantity is 1000 934.16 and total cost for the B2 quantity is 1740 only. So which is the total quantity of Q2 star is greater than the total cost of the B2 quantity. So in this regard, we have to choose the minimum lowest cost. So in this regard, we have to select the optimal quantity is the B2 quantity. So here B2 value is the 100. So optimal quantity is the 100 units. So this is the solution and thank you.